All right, so today we're going to go off of we're going to continue on in the packet from yesterday, I believe. We're going to do some composition type problems. I don't think that they're in, maybe there wasn't any composition problems in that packet. So we're fresh today. We're done with the packet then. That's fine. You should have that packet done for discovering inverse trig. We are not going to be collecting in said packet, but you need to know how to use inverse tangent and the inverse cotangent functions. Okay? Formative this week, Friday, so day after tomorrow, and then a test next week, Thursday, on inverse trig and the other graphs. The other graphs being tangent, cotangent, secant. So that's where we're at for today. So let's dive into it today. What we're going to be doing today is we're going to be looking at composition of functions. Now, you've done algebraic composition of functions because you had to get through algebra 2 in order to get to this where you're at right now. So what this is saying is we've got some functions up there, okay, which is fine, dandy, great, grand, and wonderful. What this is saying right here, f of g of 5. That's what that is, f of g of 5. So you work just like you would work parentheses in any other algebraic type problem. You work inside out. Okay? So I'm going to start with the 5, and I'm going to plug the 5 into g. So I'm first going to find g of 5 by plugging 5 into my g function. So that would be 5 squared plus 7. 5 squared is 25, plus 7 is 32. Then I'm going to take that value, g of 5, which was 32, and I'm going to plug that value into f. So then I'm going to find f of 32. So I'm going to plug 32 into my f function. 2 times 32 is 64. 64 plus 3 is 67. So f of g of 5 is 67. The kicker is start on the inside, work your way out. Okay? You find me, please, f of the inverse of f of 10. I get 7 halves for the inverse of f of 10. Then I need to find f of 10. And that's going to be 2 times 7 halves plus 3. And that's going to be 7 plus 3, and that's going to be 10. So f of the inverse of 10 is 10. Does that come as a surprise to anyone? Should it? Because they're inverses. They're designed, or I shouldn't say designed, they are defined as inverses. So they should cancel each other. Excuse me. Should cancel each other out. It's got a pickle in the back of my throat. terms of trig, we're going to be doing the same thing, except now we're going to have one regular trig function, either first or second, and we're going to have one inverse trig function, either or the opposite, either second or first. And it's done the exact same way. Okay? We want exact answers. We want them left in radians. Okay? So we want radicals, we want pi's, all that fun stuff. So here in number 1, I don't want to get too far along. Okay? So the first thing that we're going to do is we're going to do the arc cosine of 1/2. Cosine looks where on the unit circle? Top half, unit circle? Okay, top half of the unit circle. So on the top half of the unit circle, where is cosine 1/2? Yeah, pi over 3. Because I would agree with pi over 3. Okay? Then what we do next is now we take the sine of pi over 3. Well, what is the sine at pi over 3? Root 3 over 2. So the sine of the arc cosine of 1/2 is square root of 3 over 2. You try that. So first one is inverse sine of negative root 3 over 2. Where does that, or what's the result there? Negative pi over 3. Okay? Because that's right half of the unit circle. Negative pi over 3. Second one then is what is the cosine at negative pi over 3? Cosine at that negative pi over 3 is 1/2. So the cosine of the inverse sine, cosine of the inverse sine of negative root 3 over 2 is 1/2. Try those two. Now, when you got a function and then you put it into its inverse, you shouldn't have to do any work, right? Right? Because those two functions should just cancel each other out. Okay? And I will say, yes, sometimes. Okay? So in this first one, they should cancel each other out. I'm taking the inverse of the function of, it should be pi over 3, right? Okay? Well, let's check it to make sure that it is. So, sine of pi over 3 is going to be root 3 over 2. Then the inverse sine of root 3 over 2 is pi over 3. So this one is pi over 3. Yes? Okay? Makes sense. Our world is normal. Okay? Right? On this bottom one, what should it be? You want it to be 5 pi over 3, right? Because those should cancel each other out. But here's that special case. Let me show you. So, we got the sign at 5 pi over 3. What is the sign at 5 pi over 3? Negative root 3 over 2. Which then means I need to find the inverse sign of negative root 3 over 2. Well, where am I looking now for inverse sign? Right half of the unit circle, right? 5 pi over 3, yes, is in there, but does 5 pi over 3 fall within the acceptable values of inverse sign? It doesn't, so this one actually is negative pi over 3, which is the same as 5 pi over 3, but inverse sign won't give us an obtuse angle. Excuse me, actually, that's a great angle. 5 pi over 3 is a great angle because it's bigger than 180. Okay? Inverse sign won't give it to us. So inverse sign only gives us acute angles. So that's why we have to at least strip it. Okay? Now, so we've been on the unit circle. We've nailed that. We've got that all down pat. Now, let's jump off of the unit circle. Okay? Let's get off the unit circle. So, I'm looking at arc cosine of 4/5. If I'm looking at that, in which quadrant is arc cosine positive? Look at top half of the unit circle because it's arc cosine. In quadrant 1, the values are positive. In quadrant 2, the values are negative. So I'm looking in quadrant 1. So I'm going to draw myself a quadrant 1 triangle. I'm not going to lie to you, that's a pretty impressive right triangle right there, if I can say so myself. Okay? So it's a quadrant 1 right triangle. I've got this theta. That's what this is going to be. It's going to be of some theta. Okay? I know that in that triangle, because I'm dealing with cosine, that cosine is adjacent over hypotenuse. Which means, because I know the Pythagorean theorem, that means that this missing side is 3. So if I say that the arc cosine of 4/5 is theta, because arc cosine the inverse functions give me angles, regular functions give me values, inverse functions give me angles. So because that's going to give me an angle, I'm just going to say I want this to be the sine of that theta. And the sine of that theta is SOHCAHTOA, opposite over hypotenuse, so it would be 3/5. So the sine of the arc cosine fifths is 3/5. Questions on that? You tried the tangent of the arc cosine of -8/17. So the arc cosine of -8/17 is going to give me an angle. And so I'm basically looking for the tangent of that angle. Well, am I in quadrant number 1 or am I in quadrant number 2? I'm in quadrant number 2. Cosine means that this would be my -8, this would be my +17, and that's going to give me what for a missing side? Do we know? 15? No? 15? Okay. If you didn't know right off the start that was 15, we'd have 17 squared plus, oops, not plus, got the breaks, that's equals. Equals -8 squared plus y squared. What's that? 289. Okay. So then the tangent of that, so this is my theta here. So the tangent of that angle is going to be the opposite over the adjacent again. So that would be 15 over -8. Yes? Good. Good. Again, I remind you that on Friday you'll have